So very first of all, we start with the given problem statement. It starts with the estimated autocorrelation sequence of the random process x of n for the lags represented by k is equal to 0, 1, 2, 3 and 4 are represented are the Rx of 0 is equal to 2, Rx of 1 is equal to 1, Rx of 2 is equal to 1, Rx of 3 is equal to 0.5 and Rx of 4 is equal to 0. Now we have been asked to estimate the power spectrum of the discrete time random process x of n for the following case known by x of n is a MA in bracket 2 process here. So as we are already covered in this chapter the various power spectral estimation techniques right from the periodogram, modified periodogram, Bartlett, Welch's method, Blackman 2K method, minimum variance method, the maximum entropy method and into the parametric approach, the autoregressive here. So this problem is very similar with the same given details as we have solved for the previous case of the autoregressive spectral estimation technique there. So now in this case the same given details we have to use for the power spectrum estimation when the input discrete time random process represented by x of n is MA in the bracket 2. So I can say that it is the second order moving average discrete time random process here. So in the previous video as we have understood how to determine the estimate of the power spectral density for such a discrete time random process that has been generated by the use of filtering with respect to the noise W of n. So thereupon we have seen the two approaches, either to make the use of estimate of the auto correlation sequence or to make the use of estimation of the filter coefficients represented by Q here. So B suffix Q, thereupon we have represented the first approach, that it is the use of autocorrelation sequences. The estimates here will be the quite convenient as in the given problem statement we have the autocorrelation sequence estimation readily available. These are Rx of 0 is equal to 2, Rx of 1 is equal to 1, Rx of 2 is equal to 1, Rx of 3 is equal to 0.5 and Rx of 4 is equal to 0. So by making the use of the first approach that we have learnt in the previous video, we can represent capital P cap suffix MA as a function of e to the power j omega. This is equal to, for the second order we have the summation k is equal to minus 2 to plus 2 operated over the estimate of the autocorrelation sequence Rx of k in multiplication to e to the power minus j times k into omega. Now in this summation we can make the substitution from the available estimation values of the coefficients here, and thus it results to the form 2 added to twice of cosine omega further added to twice of cosine of twice omega. So this becomes the required answer for the estimate of the power spectral density when the x of n is of the type MA in the bracket 2, the random process here.